Okay, this is a video that covers some ideas behind free body diagrams, and the interesting point I think about this particular problem is how you can have a free body diagram for various points of a system. Okay, so for example, we are looking at a free body diagram for the cylinder, cylinder A, and also cylinder B, and then the connection point D and the pulley E. Okay, so there's two different cylinders and two different connection points. Okay, so if I get started, I would consider cylinder A. So I draw a rectangle to represent that cylinder. All right, and what do I have? What are the forces acting on A? Well, at the center of A, I would have the weight, mass times gravity, so the weight of A. All right, and then it's connected with this cable that goes straight up, and so I have a tension force counteracting that. Okay, and so later on we'll get more into sum of forces equals zero, equilibrium kind of questions, but for now, there's the free body diagram for A. All right, and so the power of a free body diagram is it simplifies things. It lets you break apart the system and to attack the problem in a systematic way so that you can come up with the final solution. Okay, so let's do B. All right, so B is a similar type of approach where we have a cylinder and we represent that with a rectangle. All right, we know that the cylinder also weighs something. All right, so it would be the weight of B, and again we have a tension force going straight up. All right, so very similar. All right, now let's take a look at the pulley E. All right, so we can represent the pulley with just a point. All right, or you could draw the shape of the pulley, but what we know is that the tension in the line for the pulley is the same, okay? And so we have extending from the pulley the weight or the tension from the cable B, all right? And then another force that's acting would be this force coming here at 30 degrees. Okay, we could call that tension DE, and later on use our theory that this is a pulley and that tension DE has to be the same as tension B. Okay, and so we draw that direction here. This would be the force of the cable in tension. Remember, cables can only be in tension from the reading. Okay, and then there's a force exerted on the pulley where it's being held up, okay, by another cable. All right, and so that would be a force that pulls up the cable, and you could call that tension EF. All right, so that's the free body diagram at point E. All right, and finally, point D. All right, so back to my diagram. From the diagram, there's a cable that is going to be pulling on point D. All right, moving out, tension DC. Okay, there's a cable that holds the cylinder. Okay, so that's going to be pulling on that point as well. Tension A, we've already labeled that in another diagram. Okay, so we use the same force label. All right, and then finally we have this tension pulling, tension DE, and this is acting at 30 degrees. Okay, so we have our geometry incorporated in that and also the forces. All right, so this is the basic idea of a free body diagram, and you end up breaking this up into the different components that you would need for solving the problem. So that was the point on this one. We didn't actually need to solve it yet, but there we are. Here's the solution to problem 4.6.